Okay, so we would like also to continue the load and store instructions that will give a little bit more explanations and examples. Just to remind you that with the load and the store, with this instruction, I can access the memory. I can take stuff from the memory to the register or the other way around. If I would like to take things from the memory, move it or copy it from the memory to the register, I will use load word. If I would like to go the other way around, meaning from the register to the memory, this I will use store word, SW. So load word is from the memory to the register, but store word is from the register to the memory. Just for you, easy to remember that, it's like store. If you are at your house and you would like to store an apartment and would like to store in another place, usually you need a bigger place, and that's why you need to move from your stuff or your place to a bigger place. It's the same with the CPU. The CPU inside places the register. If I have a huge amount of information that to be saved, I will use store word SW to save it in another bigger space, which is the memory. To store from the register to the memory, for example. The other way around, load word. So I will load information from the memory to the register location. But that's fine. This is the big picture. But if we would like to think a little bit in details to understand how we can do that, what will be the step-by-step actions that a machine or a robot need to take in order to satisfy my request. My request would be either move or copy from the memory to the register or copy from the register to the main memory. We would like to look at that a little bit deeply and dive in. Let's try to think together what would be these steps. Suppose that I would like to copy information from the main memory to my register, to my local address, to my local place. First of all, I need to know from where exactly I should move and to where I should move the stuff, correct? From where to where, correct? So this means that I need two addresses. First address is from where inside the memory, and the second address is to where exactly in the register. Agree? Okay, so that's fine, and everyone should follow this kind of scenario. Address from, and also the address to. To where, from where. Okay. So as soon as I will know the address from where inside the memory, I will go to that particular address, grab whatever inside that address, and then take it to the address I'm going to inside my register, and then I will copy this particular data or that particular information inside a certain location in my register. The next question is how you will get that address. Will it be an implicit number, or will it be another way to get that number? Suppose that you are working in a secret place, secret intelligence or something like that. Of course, we would expect that they will not give me the number directly. So they will not tell me, for instance, go to address X, Y, and Z directly inside a certain place to get the important information from. With the same concept, this is what we usually do when we are trying to target a certain address in the memory. Suppose that the target address that I am aiming to is 204. Suppose that this is the home address that I would like you to go to. I will not give you 204 just directly like that. You need to do a little bit of work in order to get that particular number. Let's go through these particular steps. First, I will give you the 200. Second, I will give you the 4, and then I will ask you to make the addition. But it's not only that, it's even more complicated than that. I will not give you the 200 directly. I will tell you, please go to a certain particular address inside the register, open that drawer, see what is the number there, and then add it to 4. of course, you should expect from that particular example that when you will go to a certain address inside the register and open the drawer, you will find 200 inside. Correct? But this is not usually the case. It might be any other number. But can you see? I'm just like looping until I get to that information, which is 200. And again, with the 4, I will give you this separately from that. But you need to go to that particular drawer and then open it, take that number, add it to 4. Then now you know exactly where the address in the main memory. But remember, the 204, which we are targeting in that example, is only the address of a certain particular place inside the main memory. I didn't tell you what exactly you will find inside that address. It's a secret agent. You will only know the address. You will go to 204, blindly, you will take whatever is there and copy it to a certain particular address inside my register. So 204 does not have any relation with what is inside that particular address. I give you the address of the home. I'm telling you to support like a certain message or so, or take whatever is there. You don't know in advance what is there. Just take whatever is there, move it, or copy it to another particular place. So that means if I would like to give you that 200 example that I mentioned, instead of telling you 200, I will give you the address of the drawer inside my register to come and open it to know that there is a 200 there. So suppose I may tell you like go to register S0 or go to register S1 or go to whatever the register name is. And from the table, you'll open the table and see like what that register means or what is the number associated with that register. Suppose you target S0 and for example, S0 is drawer number 17. So you just go to drawer number 17, open that drawer and you will find for that particular example, the 200 inside that drawer. And then I will tell you separately, please add 4 to that 200, then you will do 200 plus 4. And then you will go to the memory to add this 204. Look, where is 204? I found it, grab whatever inside there, copy that to another address that I will also give to you inside my register. Suppose I give you T0. And you look at the table, what does T0 means? You look at that table, you find that T0 means, for example, the 7th slot. So you will dump whatever you found in the address of 204 from the memory to the register to T0 inside my register. Okay, this is what we will exactly do right now. But first, the computer needs to understand all whatever we are mentioned right now and all whatever we can see by our eyes and write by our hands. So go to that example. As you can see from here, load word T0, comma, constant, and then particular location. Meaning that you will go to that particular location and then take whatever in there, copy it to T0. But that particular location, as I mentioned, I'm giving you in 2 steps. First step, in order to find the 200, please go to S3. And S3, if you go to the table, you will find that S3 is slot number 19 inside my register. Go and look at whatever in there, open that drawer. You will find a certain particular number. Please add that number that you will find to 24. When you will add that number to 24, so this means that you already knew what is the address inside my memory. After you know exactly the address inside my memory, please grab that information, copy it to T0. I would like also to remind you that we have an R format and I format. With the R format, if you recall, we had opcode, we had RS, we had RT, we had RD, destination register, we have shift amount, and then we have function. Unfortunately, none of these can hold a constant value. If I would like to write the 24, where I supposed to write the 24 here? I can't, because nothing of the terms inside my R format can accept a constant value. And that's why we had an I format. remind you again with an I format. I format is opcode, the first 6 bits, then the next 5 bits RS, the next 5 bits is RT. And as you can see from here, all of these till now is just common between I format and R format. After the RT, its things are different. So instead of having RD, destination address, and shift amount and function, we have just a constant or a certain address that we can use in any of the cases. Okay, so I would like actually to write this stuff. So the computer, as soon as we'll see a certain particular zeros and ones, will understand that this is what it means. Or as an example, I give you these things and I'm telling you transfer it to zeros and ones, which will exactly means the same. How we can do that? First of all, the computer needs to understand that this is load word. So I will go to the table and see that load word means number 35. The opcode of load word will be 35, and this will be given to you. So you will get from the table 35, you will write here 35. So as soon as the CPU will see here 35, it will understand that my command is load word. How about the other? Load word is copying from here to here. Okay, so I will suppose that this will be my first source. So S3 from the table is 19. So I will just write 19 here. I am copying 2 here. So this is my second source in this case. So T0, I will go to the table. I found that this 8. So I will copy 8 here. So I copy from this to that, from this to that. And then where is the 24? The 24 is constant. So the only place that I can write the 24 is actually here in the constant. So as soon as the CPU will see this number, of course, transfer it to binary or to hex number. As soon as the CPU will see all of these numbers concatenated, it will understand that it means that particular example or that particular instruction. I would like also to highlight an extremely important thing, that suppose that instead of store load word, I have here store word, for instance, and everything else here is the same. Store word, and I have everything here the same. However, the meaning will be a little bit different, because with a store word, I am moving or copying the stuff that is in that particular slot in my register to that particular address location inside the main memory. However, although I begin from here and this is the end, I will deal with RS and RT exactly the same as the load word, meaning that this will be also here, this will be here. However, the CPU, as soon as we'll see another opcode here that corresponding to store word, it will understand actually I am copying from here to here instead of here. So remember that. If I were to give you store word with that things, this still has to be here and this still has to be here. Okay, so now we understand that as soon as I will have these numbers, the CPU will understand that this is the case. So again, just to refresh whatever we have mentioned, we will open in my drawers the number S3. So I will go there. I will find the 19th slot. I will look at whatever is there and then add 24 to that. Then I will have my address that I would like to go to in my main memory, which with our example was 204. If you open here, you will find that there is 200. And when you add it, it's not 24, it is 4. So basically you will find that this is 204, just as an example. Okay. However, when you do that, when you open these 19 slots, you will find whatever in S3 is basically that particular number. Again, there is no relation between 19 and that number. I only told you, please go to slot number 19. You might find a number 200, or you might find that number. You might find any number there. What I'm telling you, as soon as you find that secret number, add this constant to that number. In this case, it is 24. When you add this plus 24, you will get that number. Hey, this is the address of the slot that you are targeting. So now you arrived to the home that I would like you to go to, which is 204 in that particular example that we made. In this case, will be that number. So now you arrived to the correct slot. What you need to do next? All of this hassle is just where I should get the data from or the stuff from. All of this hassle till now with all of these and then plus 24 until I arrive at. This is just the address of whatever I am targeting, correct? What is next? You arrive to the data, to the address that you are targeting. What is next? The next thing to do is copy the information in that particular address that you found in that particular address to T0. T0 is a slot number 8, meaning that you will take whatever is here, which you don't know what is that. Blindly, you will take whatever is here that is pointing out with this address. You will take whatever is here. Please copy that in T0, which is basically slot number 8. 8th slot inside my register, copy that here. As soon as you've done that, then the job is finished. That's all. So what is all of this? This is just addition of this plus 24. That's all. How? Look at this number, 490 and so on and so forth. So we transfer that to binary. You look at this first 4 digits is 4, which corresponded to this. The next is 9, this is 9, and so on and so forth. How about the 24? I told you add 24, transfer this to binary. If you look at this, this is simply 24 in binary. Do the addition, binary, transfer back to hex. You'll find that number, which is that number. So this is not but this plus 24. That's all. So when you add this to that, you arrive to this particular number. Oh, hey, this is my secret address that I have done all of these steps until I arrive to that. Finally, I got to the address that I would like to go to. Okay, so you are at this particular address inside the memory. Does not have any relation with what is the data inside that particular location, which is here as I mentioned. This is not the data that is inside here. This is just where it is located. You are going through the memory until you arrive to a certain particular slot. Oh, I am here. This is what I would like to take the data from. Take the data from that, copy it, go to T0, at this because of this, T0. Go to T0, copy this data inside that T0. So you already knew right now, if you look at T0, it has the same information that is pointing out by that particular address. So whatever is in here will be also in T0. So if you recall with the R format, we have been able to do a bitwise AND, a bitwise OR, a bitwise NOR. So this T1 ended with T2, put the results in T0. This OR, T1 with T2, put the results in T0, and so on and so forth. But as you can see from all of these commands that there is no constant at all. Everything is inside a register location. Instead of telling you like a certain number, I'm telling you go to a certain location inside my register. Certain slots, if you will. But what if I would like you to end one of these slots to a certain particular number, constant number? How we can do that? I can't use an R format. If you record in the R format, there is no way that I can write a constant. In all of the types, in all of the items inside my format, there is no place to write a number. That's why I need to use an I format. And that's why I need still to do an AND operation, but using an I format instead of the R format. And because of that, we will use this I. So it is AND immediate or AND I. So then I can actually AND a data that is inside that location to a certain particular number. And again, it is bitwise AND. So this will be AND with that, and then the results will be allocated here, or I, this will be with that, and then the results will be here, and so on. There is also a conditional operations, meaning that I will check a certain condition and do accordingly a certain action. There is something called branch to a labeled instruction. Let's take an example to understand what does that exactly mean. There is a command called BEQ, branch if equal. Branch if equal. So this means that I will check if RS is equal to RT or not. If they are equal, please branch to L1, meaning go to L1, and L1 will be a certain particular address, as we will cover in details later on. So I'm checking. Go and check whatever is in RS and see if it is equal to whatever is in RT or not. If this satisfied, please go to that particular location. If not, what I'm supposed to do? Just to go to the next instruction in my code to be executed, just to follow, go to the next instruction. Let's take another example. BNE. It is branch, but if not equal. So if RS is not equal to RT, please go to that particular location, which is L1 in this case. That's why I condition. Check if they are equal or not, and then go to that particular location if it's satisfied, or branch not equal means go to that particular location if they are not. There is also an unconditional branch or unconditional jump, as you can see from here, by using a J command L1, meaning jump to that particular location, independent on a certain condition. Jump to L1. Okay. So after we already knew this information, let's try to see or to solve that example. I'm giving you here a code in a higher level language, supposed to be in a C code, for instance. And the target is to transfer that to an assembly language. Let's go through this example step by step, so you will be aware how we can do that. The code is saying that if I is equal to J, please do that. Put in F the results of G plus H. Else, allocate in F the subtraction of both of them. So if I equal to J, please do the addition. If not, do the subtraction. And then exit, and then exit. I also can write this a little bit differently. I can tell you if I is not equal to J, please go do this, else do that, correct? You can do it the other way around as well. Yes? Okay, but before we would go to the assembly, we need to know in advance the locations of these variables, because these variables has to be saved in a certain particular location that the CPU can access, correct? And because of that, we are giving you this information in advance, that the variable f is already saved in location S0, G is in S1, H is in S2, and so on and so forth. So all of this information is given in advance. You know that. So then you have everything to go with your assembly code. We will check it that way. If I is not equal to J, we'll do something, which is that. Else, we'll do it. Okay, so if I not equal to J, I is saved in what? I here is in S3. So I will check if S3 not equal to J. J here is basically in S4. So this is not S4. So I will check if S3 is not equal to S4 or not by this command. Branch if not equal. If this is not equal to that, please branch. And of course, if it is not equal to that, we need to do what? We need to do a subtraction. And that's why I will have this address as an L1. L1 here is just not but a subtraction. Subtraction of what? Subtraction of G minus H. So I subtract G minus H. Where is G? G here is an S2. So that G here, sorry, is an S1. So that's why I have here S1. This is G. H, where is H? H is here, is an S2. That's why here I have H. Subtract this G minus H. G minus H has to be where? In F. Where is F? F is in S0. That's why we have here F. So G minus H, put that in F with this command. Okay. This is if not equal. If this is not equal, then you will do that. What else? Else, you will do the addition. So this means that if that command is not satisfied, what you need to do is, instead of going to L1, you will just go to the next instruction to be executed. And in this case, you would like to do the addition. And that's why here they have the addition. The addition between what and what? The addition between G and H, and put the results in F. That's why add G and H, put the results in F. G again is S1, so S1, this is G. As we have seen, S is in H is in S2, and then F is in here. So you actually add this with this, put the results in F, which is that. Okay, that's fine. So if I'm done with this, or if I'm done with that, I just need to exit. And that's why the next instruction after that is just to jump exit. Or if I have done that loop, if I have done from here to here, after that instruction, I just again need to exit. That's all. Let's take another example. It's given to you also a higher level language code with this is like called the C code, for instance. And the code is as follows. While save of I is equal to K, please increment I. That's all. One line code. And we need to write that again in assembly. So while something equal to something, then increment the I, meaning increment the array element in another meaning. So if you begin with array save of 0, then increment the I plus 1 plus 1 and so on. Again, you need to have information in advance about where the allocation of the variables, and this will be given in that case as well. I, it is given, it is in S3. So this I is in S3. K is in S5. And the address of save in S6. What does it mean, the address of save in S6? Meaning the beginning of the array saved is in S6, meaning that save of 0 in this case, because I didn't tell you like any other things, by default I will begin with 0, basically in S6. So the beginning of the array has this particular address. So again, what we need to think from the big picture, while save of I equal to K, is incremented I. As save is an array. And because that it is an array, it is already in the memory. I don't expect that an array will be in a register. In the register, there are 32 slots. How I will save an array of like 100 items or 100 slots, and where I should save that? I can't. This has 1,000 locations. How I can do that? So basically, the array will be in the memory. So the array save will be in the memory. And I need to go to C, save of 0, the very first element of the array. If that element, number, or whatever already saved inside that array item or number, is it equal to K or not? So I have the memory. I have my array, and this array is 1 by 1 inside my memory. And each time I would like to check if the data that is inside that particular item is equal to K, which is inside the register or not. K, as you can see from here, K is in S5. S5 is a certain slot number in my register, correct? So that means that each time, since I can't do this comparison that easily, each time I have to go to bring the location of my array element, copy it to my register address, and then do the comparison. If they are equal, please increment I and then go to the next address of my array. Do the same exactly things again. Copy that data to my register, compare the results. If it is okay, increment, otherwise exit, and so on. So that means that I have each time to go back and forth between the array or a certain address of the array inside my memory, and then copy it to my register, and then do the comparison. Correct? But there are a couple of things we need to know. Is okay, so I have an array with 1,000 elements as an example. I need to know what is the beginning address of that array, correct? My array may begin from the very beginning of the memory. It might begin from an address X, Y, and Z, or it might, X, or it might begin from the very whatever the address is. I need to know that now. It is given here. It is given that address of save in S6 is in S6, meaning the very beginning of the array, save of 0, the very first element of the save is basically in S6. So that means, do you remember the idea of the 200 that I mentioned? You have to go to a certain slot and open that drawer and you will see the 200. Here's exactly the same. You don't know what is inside, you don't know exactly what is the address. Please go to that slot, open that slot, and then you will know what is the address of save of 0. As soon as you know that address, then you will use a load word to copy whatever the information there to a certain particular location of your choice inside my register, and then you will compare it with where is the location of the K. Correct? If they are equal, you will increment, otherwise you will exit. Okay, so that's fine, we can do that. But there is also another important information that you need to ask, or you need to think about. The other information that you need to understand or you need to think about it is what is or how I can get the address of my next element. So if I already knew the address of save of 0, how I would know or how I could know the address of save of 1? How I can know this information? Suppose I gave you the address of save of 0, suppose it is 200. What is the address of save of 1? You may think that it should be 201. Correct? You may think that it might be another thing. What control you? The most important thing that should control you is how many bits inside each element and what is the slot size of my memory. So if my memory is 32 bits width, the width is 32 bits, yes, and I have my array element, each one of them is 32 bits. If it is 32 bits, I can allocate that in one row. And then save of 0 will be 200, save of 1 will be 201, save of 2 will be 202, and so on and so forth. Because the width of each of the element of my array is 32 bits, and my memory width is 32 bits. Correct? So I can write 32 bits inside one row. So I can just increment by 1. However, by default, and unless otherwise specified, my memory width will be 8 bits. And the width of my array, we agreed that we are working with 32 bits, so it's still the same, unless otherwise specified. So by default, the element width, each of the elements has to be written in 32 bits. Unfortunately, my memory is only 8 bits. So this means that each of the elements, how many rows I'm taking inside my memory? It is 32 divided by 8. So that's mean in order to write 32 bits, I need to use 4 of the slots in my memory. So that means if save of 0 at 200, to write whatever inside 200, it will take 4 slots. So save of 1 will be 204. Yes? And then the after one will be 208. So each time I have to add 4. Correct? So suppose I'm asking you where is the address or what is the address of save of 5. So this means that you have to add 4 plus 4 plus 4 plus 4 5 times. But you can do that easily since we already knew multiplication. Correct? So what you need to do is what? Save of 5. Oh, hey, I'm just adding 4. So 5 multiplied by 4 is 20. So you need basically to add 20 to 200. As an example, correct? Then you already knew that you need to go to 220, and you already understand that 220 is pointing to address save of 5. I may give you save of 6 or save of 7. You just need to do the multiplication with 4. Why 4? Because we have 32 bits. Why? Width is 32 bits of my each element, and the width of my memory is 8 bits. Suppose that the width of my memory is not 8, it's 16. So how many slots I need to fill? 2, because 32 divided by 16 is just a 2. So I will increment by 2. And this is very close to our actually incrementation in our life. If you recall in the streets and house numbers or apart or whatever, like buildings number, but we usually have that just count by 2 in one side, and the other side we are counting by 2. Yes, but one side would be the even and one other side would be the odd. So if you were to find a building that is 200, for sure you know that the next one is not 201. The next one in the same side is 202. So you are counting by 2. So if I were to tell you like, okay, so where is the 10th? Again, 10th multiplied by 2, 20 plus the 200 is 220. So the address will be of that building will be 220. Correct? On the other side, you will find the 201, 203. And so on and so forth. It's still counting by 2. There might be in another country that we are counting by 4 for whatever reason. Correct? So, but this is something that we agreed on. They might say like, okay, that side we are counting by 4 because we have 4 sides. And if this is 200, 201 would be here, 203 would be here, 204 would be here, or whatever the thing is. Correct? We have to agree. And according to whatever we have mentioned, if I am having 32 bits, and my memory width is 8, so that means that I need 4 slots. Okay. So remember that we need to do that. We need to multiply by 4. I will get an address, add that to the base address, which is 200. Then I will know exactly where to go. Suppose that this is the case. Try to apply the same concept here. But I would like to remind you about very important stuff that we mentioned earlier. That if I would like to multiply, the best thing to do, if I can, is to do a shift left. And if I would like to multiply by 4, this means that I have to do shift left by 2. Because shift left by 2 is not but multiplication by 4. And what's exactly I need to multiply by 4 is the element number of my array. In this case is I, because I is changing, correct? So I need to multiply I by 4. Okay, this is what we will do. Where is I? I is in S3. So S3, please shift left by 2. Okay, so this means that I multiplied by 4. Please put the results in a choice of my self is T1. So that's mean that here now I have I multiplied by 4. What I need to do next is to add that number to my base address. Correct? What is my base address of the 200, which is this in S6. So what I need to do next after I have I by 4, which is this, please add that to my base address. So if this is 200 and this is for instance 4, I know that now I am targeting 204. My next I. Or if it is 8, it would be the next one, and so on and so forth. Okay. After this, I already knew that I have in my hand now the 204. So I know now the address that I am targeting, or the address that I would like to go to. As soon as I will arrive to that particular address, what I need to do next? I need to do the comparison, correct? Because I would like, if you recall, I would like to check that if this is equal to that or not. How I supposed to do that? I know now the address. I will just grab or copy this information that I found to my register. And after I copy that, then I need to do the comparison. First, copy. How I can do the copy? Load word. Load word from that particular location to a certain location of my choice in the register. This is what I will do. Load word, that particular location, which was 204, which was allocated already here, to a certain location of my choice. I may choose any place. Please move or copy that to a location called T0, which have the save of I. So T0 will hold the save of I. As soon as I will have the 20, please compare it to K. Whereas K is an S5. So please compare it to K. If they are not equal, please exit. Because if they are equal, I need to increment. That's why if they are equal, just go to the next line, please increment my I. And after that, just again loop with different I's and so on.